afternoon, students. So the last topic of our third module is ground improvement techniques. So what is meant by ground improvement techniques and why we are doing this method? So these ground improvement techniques are usually done on soft soil deposits because these soft soil deposits have low bearing capacity, and this type of soil will exhibit large settlement when we are subjecting external loads. So this type of soil should have some improvement technology so that its shear strength is increased, so that we can impose loads without any failure. So this type of soil should be improved by some techniques, that is ground improvement technique. So it is inevitable to treat soft soil deposits before constructing some buildings over it. So this ground improvement techniques are done in order to prevent differential settlement. So we can prevent the potential damages to the structure. Okay, so in order to prevent the differential settlement of the structure, it is very important to treat soft soil deposits prior to construction activities. So we can discuss what are the different methods in order to improve the shear strength or bearing capacity of the soil. And this ground improvement techniques firstly introduced by Bergado et al. In 1996. And this ground improvement techniques can be broadly divided into two categories. In the first type of method, this is a technique which require foreign materials and utilization of reinforcement. That is, we are applying foreign material or some reinforcement are imparted into the soil, and it will increase the bearing capacity. And they are based on stiffening columns either by the use of granular fill or stone columns, by piling elements which are not reaching a still soil stratum, or by in situ mixing of the soil with chemical agents. Okay, so in this method, in the first technique, we are applying some external agents or some reinforcement to the soil and improves its shear strength or bearing capacity. In the second technique, it includes strengthening of the soil by dewatering. That is, here we are using preloading techniques, which is combined with vertical drains. That is, we are applying load on the ground surface before the construction of the buildings, and water is dewatering process done. That is, consolidation is continued. So this is another technique. So mainly there are two techniques to improve the ground property. In the first technique, we are applying foreign materials and utilization of reinforcement, and in the second technique, we are strengthening the soil by dewatering. So that technique is preloading techniques. So we can discuss these techniques one by one. So first ground improvement method is preloading or pre-compression. So this preloading is surcharging the ground with a uniformly distributed surface load prior to the construction of the structure, like buildings, embankments, motorways, and runway tanks. That is, before constructing structures, the structure may be any building or some subway or runway tanks, embankment, etc. So before constructing these type of structures, we are applying surcharge load on the ground. Okay, that is the techniques of preloading. That is, we are applying surcharge to the ground surface with a uniformly distributed surface load before construction process. And the purpose is to take up the settlements under the civil engineering structure before they are built. That is, before constructing our building, the settlement settlement will be completed due to the surcharge weight. Okay, so after constructing this structure, there will not be any settlement. So the building will be safe. So that is the technique. That is, before constructing our structure, that ground surface is applied by some surcharge load. So the settlement will be completed during that period, and after completing the settlement only, we are constructing our structure. So our structure will be safe. So that is the technique of preloading or pre-compression. The soils which is suitable for preloading are compressible soft to medium soft saturated clays and silt, then organic clays, peats. So these type of soils are usually suited for preloading technique or pre-compression technique. So this figure shows preloading or pre-technique. That is, we are applying a surcharge load over the ground, and there will be settlement due to the surcharge load, and after the application of final load, there will be settlement, but that settlement will be very small compared to the initial settlement, so our building will be safe. So this is the method of preloading. And the types of preloads, there are different types of preloads, that is different types of surcharge load. First one, earth fill. That is, usually we are filling the ground with earth fill, and it is the most common technique. Then water in tanks or ponds, so that water is a kind of preload. Then vacuum application under a membrane, then special anchor and jack systems, groundwater lowering, electro-osmosis. So these are the different types of preloads. And the surcharge results in, that is by application of the surcharge or by applying the surcharge load, it will result the primary consolidation settlement, secondary consolidation settlement, and increase in undrained shear strength of the soil. That is, due to this application of surcharge load, the primary consolidation occurs, that is removal of water from the pores, and also secondary consolidation occurs. Finally, the shear strength will be increased. Okay. So these preloading techniques are mainly of two types. First one, conventional technique, and second one, vacuum preloading. In the conventional technique, it is the simplest solution of preloading, and it is usually by means of an embankment or earth fill. Okay, so when the load is placed on the soft soil, it is initially carried by pore water, and it will if the soil is not very permeable, the water pressure will decrease gradually, because pore water pressure will be very high. So total stress will be equal to, that is effective stress will be equal to total stress minus pore water pressure. So this water pressure will decrease gradually. Because the pore water is only able to flow away very slowly if it is less permeable. Okay, that is when load is applied. Simply when we are applying load, there will be escape of pore water. Okay, so shear strength will be improved. So in order to create any stability problem, the load must mostly be placed in two or more stages. That is, if you are applying the complete load in one stage itself, it may cause some stability problem. Okay, so we are applying the load in stage by stage. That is the conventional preloading method. So this is the ground level. So we are applying this preload or surcharge weight is here, and there will be slow drainage of the subsoil, and slow settlement will occurs due to the application of surcharge load. So that is preloading. Next method is vacuum preloading. Okay, that is I will explain one more. That is, in conventional preload, usually we are doing this method by means of an embankment, earth fill, etc. That is the usual method. And in vacuum method, vacuum preloading, here this is the simplest method of vacuum consolidation, and it consists of system of vertical drains and drainage layer. That is a simple case of vacuum. That is, we are applying vacuum pressure instead of the surcharge load. That is, we are not applying any external earth fill or embankment or water, etc. We are just applying pressure on the surface of ground so that settlement occurs. That is a method of vacuum preloading. That is, sometimes soft soil may be so weak that even a common 1.5 meter embankment might cause stability problem. That is, if the soil is very weak, we cannot apply the conventional method of preloading. That is, when we are applying any embankment or earth fill on the weak soil, it may cause a stability problem. So at that situation, we are adopting vacuum preloading. And Gell-Mann was the first who introduced vacuum preloading to accelerate consolidation. In vacuum consolidation, the surcharge load is replaced by atmospheric pressure. Okay, so by using this atmospheric pressure, we are applying settlement for the soil. That is, preloading is completed. So that is a vacuum preloading. And in its simplest form, the method of vacuum consolidation consists of system of vertical drains and drainage layer on top. And the common advantage of vacuum preloading are there is no extra fill material needed. That is, we do not require any extra fill, and the construction time are generally shorter, and it require no heavy machinery extra. These are very advantageous method, because we do not require an extra fill, and construction time will be very low, and it require no heavy machinery. Moreover, no chemical admixture will penetrate in the ground, and thus it's a environmental friendly ground improvement method. So vacuum preloading is one of the best method of preloading technique. Here we are applying surcharge load by using atmospheric pressure. So this is preloading technique. Okay, this figure shows vacuum preloading. That is, we are applying atmospheric pressure here, and settlement occurs for this layer. Next is vertical drains. Next method of ground improvement is vertical drains. So preloading technique may not work sometimes alone due to a thick uniform soft clay layer or permeability of the clay is very low. That is, if the permeability is very low and if the layer, that is soft layer, soft soil layer is very thick, we cannot apply preloading only. That is, preloading is preloading itself will not be efficient for such type of material. So the time for pre-compression is very long and not practical, or the surcharge will be very high for reasonable waiting period. That is, it will take long period to complete the escape of pore water. Okay, so in order to reduce this timing, we are applying vertical drains also. So because of its low permeability, the consolidation settlement of clay take long time to complete. And to shorten the consolidation time, we are installing vertical drains. Vertical drains are installed together with the preloading, either by an embankment or by means of vacuum pressure. Okay, that is, here we are doing vertical drain with preloading. That is, in some cases, if the permeability of the soil is very low and also if the thickness of the clay layer is very high, it will take long time to complete the consolidation. Okay, so in order to increase, or in order to rapidly do this work, we have to apply vertical drains in accordance with, or in addition with the preloading technique. And therefore the vertical drain installation reduces the length of the drainage path and accelerate the consolidation process and allow the clay to gain rapid strength and increase to carry the new load by its own. So this is the advantage of vertical drain installation. So here preload is there, and also vertical drains are installed in order to accelerate the consolidation process. And types of vertical drains, there are different kinds of vertical drains, and sand drains are basically borehole filled with sand. That's what is sand drain. As for the displacement type of sand drains, a closed mandrel is driven or pushed into the ground, and it will result displacement in both vertical and horizontal direction. That is one type of sand drain. We are inserting closed mandrel, and this mandrel will allow displacement in both vertical and horizontal direction. And the installation causes and this installation usually causes disturbance to the soil structure, usually in soft and sensitive clays, and it will reduce the shear strength and horizontal permeability. That is, if the soil is get disturbed, it will decrease the shear strength and horizontal permeability of the soil. So the low or non-displacement installation are considered to have less disturbing effect on the soil. That is, we have to install this vertical drains without any disturbance. Okay, the drilling of the hole is done by means of an auger or water jet. In terms of jetting, installation will be very complex. So by using suitable method, we are installing vertical drains on the soil. So these are the different types of ground improvement techniques: preloading, then vertical drains. Preloading is the most important technique. In preloading technique, we are applying surcharge load and consolidation will take place, and in some cases this preloading alone will not be sufficient, so we are applying vertical drains also. Okay, so these are the ground improvement techniques. Okay, thank you.